London, one of the world's financial and cultural capitals. 8.2 million people live in the city itself, whilst a further 5 million people live within commuting distance. As Europe's most visited city, London attracts 27 million visitors every year. Every day the majority of these people go to work, to shop, or to see the many sights London has to offer. Londoners, just like the inhabitants of every other major city in the world, face the colossal task of getting around. The main roads of the city, its railways and the tube system have become overburdened and stuffed with commuters and tourists. Other routes, such as cycling or walking, are perceived by many to be too dangerous or too much effort. There are many untapped routes along the river's edge, over bridges and on the city's smaller roads that could be used for short commuter journeys, freeing up the city's networks. All that London and many other cities in the world need is a solution that gives people the confidence and ability to use these routes easily. Based on this problem, I began to do research and interview interested client groups. I looked at past products, such as the Sinclair C5, possible components and available materials. My research gave me some very interesting information, which I then collated to form the specification for the solution. Using this, I began to design draft products. Each one had an electric motor, a prerequisite that came out of the interviews. They were all also intended to be more stable and visible than a standard bicycle, whilst remaining manoeuvrable and relatively small. From these draft ideas, I chose a concept that I thought was the most feasible and that best matched the specification. I developed it further, making decisions on specific components, dimensions, and adding pedals in line with the law on non-licensed vehicles. By the end of this development, I had created a CAD model of a product that was a suitable solution, yet could be made by me using relatively simple techniques. My CAD model allowed me to create quick working drawings for each component, which I then fabricated over the course of 4 months. This is the first prototype of the product. It is a compact tricycle design that is steered by leaning. Without pedalling, the product has a top speed of 13 miles per hour, 2 miles an hour below the legal limit. Powered by a rechargeable nickel metal hydride battery, the electric hub motor can assist pedal power for longer journeys or independently drive the product for commutes. The leaning steering mechanism, a series of linkages and ball joints, joins the leaning seat to the rear wheels. The seat pivots about a point just above the frame. The bracket on the back of the seat and the bungee cord loops allow the user to adjust the sensitivity of the steering. By allowing the user to lean into the corners, the steering mechanism keeps the compact 3-wheel design stable when cornering at all its operating speeds. A bucket seat that fits snugly to the user ensures comfort, safety, and a direct steering response to leaning. The lightweight triangulated aluminium frame forms the stiff centre of the product. The whole front wheel and pedal section can be moved forwards or backwards via 2 quick release clips to adjust the product's length for different users. The rider stabilises themselves via 2 handles attached to the frame. All the controls for the product's operation are also found on these handles. Finally, a front wheel cover ensures the user is not sprayed with debris coming off the front wheel during transit. Having made the first prototype, I would say the product has a promising future. Although some changes, primarily aesthetic and waterproof ones, need to be made, it could allow millions of people to get around cities on previously unavailable or undesirable routes.